Hi, welcome back to my channel. I hope you all are safe during this COVID-19 pandemic. Today I will talk about a very important and interesting part of Foundry technology, that is the basics of casting design rules in Foundry. I will try to explain you the basics along with some examples so that you can understand in a better way. The general design rules for casting. Whenever you will try to make any casting, generally we first design its different components, how we can make the casting in a better way. So there are some thumb rules, some important rules. If we can follow that rules, then easily we can make a good casting. Design the part so that the shape is cast easily. It should not be so much complicated, because whenever we will think of making the pattern, if the part is too complicated, there are involvement of so many of core boxes and other things. So we should avoid that part. Select a casting process and material suitable for the part, size, mechanical properties. Important is the parting line selection, because the first point in the hands of method engineer is to select the parting line. If we can select the parting line at the very beginning and with a proper care, then constantly the foundry can get good casting. Locate and design the gates in such a way so that the metal can flow inside the mold cavity without any turbulence. With a laminar flow, fill up the mold cavity proper manner with uniform rate. So that is very important also. Select an appropriate runner geometry for the casting. I mean, whether the runner should be from the bottom or top. In my next videos, I will discuss in detail the runner system, the gating system. But today, I'll confine my discussion to only the how to make a casting and what are the good design rules for making a casting. Okay. Select an appropriate runner geometry is important. Look at the mold features. I mean, the sprues, screens, risers, and all these, accessories are required to pour the metal inside the mold cavity so that it can fill the cavity with the least possible time. Fast pouring but slow feeding with the lead. So fast pouring to be assured with the help of the proper runner and gating system. Make sure that the proper controls and good practices are in place. Now, these are all the casting fitting rules. And now I will talk about the geometry of the castings, like the corners, angles, and section thickness. The thumb rule in a foundry is that we should avoid any sharp corners or angles. Why? Because these are the stress razors for the castings, and a very typical defects we generally experience in steel foundry. These are the hot tear defects. So we have to avoid the sharp corners, and these sharp corners are the source of cracking or tearing during solidification. So as far as practicable, we use the fillets with radius ranging from 3 to 25 millimeter. 25 is very liberal, but as far as practicable, we should confine to 3 to 5 millimeter radius at all the fillets and all the angles, so that there should not be any sharp corners. This is the basic rule. Successful casting practice requires the proper control of large number of variables. But what are the variables? One is that characteristics of metal, I mean what type of metals you are pouring, it is important. Method of casting, what are the different methods by which you are making the castings, mold design, and various other parameters. I will discuss in detail also. Third important point is the flow of molten metal in the mold cavity, the gating system, the rate of cooling, the gas is involved during the solidification or during the pouring of the castings. All these parameters should be taken into consideration. Okay. Now, here is this slide, if we can follow that. The first one thin part is connected with a thick part, and the connection point, there are some sharp corners. Okay, that A and B, both the cases, these are the poor design, because all sharp corners should be avoided. So what we are doing now, we are gradually blending that thick to thin areas, so that any sharp corners can be avoided, which are the source of any type of shrinkage or hot tear defects in castings. So please look at this slide very carefully, and this is the basic design consideration for a foundry. Okay. Now, design consideration in castings and the different design cast parts. Now, we have seen that it's not possible to make a casting with uniform section thickness. It's not possible. Sometimes there is a blending of section thickness. Sometimes the section thickness varying from thick to thin, thin to thick, like this. So during the changes of wall thickness, there is a chances of creating hot spot. Okay, and this hot spot determine the fate of the castings. This hot spot, if the hot spots are more, it will take more time to solidify, so the isolated shrinkage will be concentrated at that area. So how to eliminate that hot spot from the casting? That is a great challenge for a good foundryman. Number 2, cavities or hot spot can be eliminated by using some sort of core also, because some of the areas, what happened, intentionally we are putting the cores to make that hot spot little bit smaller. So it is important, if design in our hands, it is not in the customer's hand, so we can manipulate this type of things like putting the core like this, so that the hot spot can be not eliminated, but can be reduced. Okay, or else, yes, this is a very important slide for the casting designer. You can see what do you mean by hot spot? The round circles which is touching the all walls of the castings, the maximum inscribed circle in a casting is the hot spot. So you can see the middle hot spot is the more, because this is a junction of two channel. Okay, so junction always creates a bigger hotspot, and ultimately during solidification that bigger hotspot is the source of shrinkage cavity. Okay, now how we can eliminate that hotspot? That is a challenge. So we can put some sort of core so that hotspot can be reduced, or we can put some sort of internal chills so that that area can be solidified at a faster rate, or else we can put some sort of riser by so that that area can be fed properly, the shrinkage can be eliminated. So there are different techniques to avoid that shrinkage, because shrinkage is not desirable at all in the final product. During different types of testing like radiography testing, that can be revealed, and that is a source of defect. Okay, so this slide is very important. Please go through this slide. There are good design of different channel sections which are connecting one into another. You can see shrinkage is coming in the poor design, but if you can blend the thickness in such a way, avoiding the hotspot, then it is a good design. So if you can, it is a self-understanding page where you can understand how we can eliminate this. You can understand how we can eliminate the shrinkage from the core of the hotspot. Okay. So this slide, please remember. Next slide. Here is also the same. There are some poor design, there are some better design, and by blending the section thickness. Okay. So we can eliminate the hotspot with the help of some core, with the help of some internal chills, so that it can solidify at a faster rate, or by providing some sort of riser with padding. Right. Now this is the concept of padding. What we are doing now? Right side diagram, if you can see this cast part, these are the isolated hotspot. Okay. Thin, thick, thin, thick. So thick as at the bottom, so it will solidify later. Thin portion will solidify faster. So what we are doing now, we are putting a riser, because there is no approach to feed the thick section. So we are putting a riser at the thin section. But what we are doing, please follow the blue color, that is the padding part, which is connected, which is indicated by blue color. Riser is blue, okay, and the padding is also blue, which increases the volume of the metal at that area. So that is the padding which eliminate the isolated shrinkage from the casting. So left side you can see, the same photographs, left side you can see there are some isolated shrinkage by putting a riser at the thin section. Right part, we are putting a riser along with pad, and that pad can feed that isolated hotspot thick section very easily, and the shrinkage can be eliminated. Okay. Now there are other design considerations, like the flat areas. Large flat areas is difficult to cast, so we can avoid as far as practicable. But if we have to cast this type of part, we will take care of this by some sort of allowances, that is called camber allowance, etc. Okay. Also we have to put the different types of risers. Now we have to eliminate the shrinkage part also from the castings. So that part covered that slide. This is the slide where the shrinkage percentage is given for different metals like aluminum, brass, magnesium, cast iron, steel, etc. Okay, so this is an informative slide. Now, whenever we are making some design, so we are considering the casting design. So draft is also an important part. What I have discussed already in my previous video, that whenever we are trying to take out the pattern from the mold cavity, so we have to provide some sort of draft. Okay, so that and that is ranging from 0.5 to 2 degree depending upon the material of the pattern or tooling we are using. Okay, so that draft is very important, but we should avoid sometimes the customer requirements is such that some of the areas they don't require any draft, perfectly straight. So in that case, what we are doing, we are putting some sort of loose fittings, and or we are covering that area by some sort of core to avoid that draft. Otherwise, we are putting the draft which are non-functional areas. Lastly, the dimensional tolerances are also very important, and would like to some of the cases in commercial practice, tolerances are generally in the range of 0.8 millimeter for small castings and almost 5 to 6 millimeter plus minus for the bigger castings. So within that range, we have to play with the castings. Okay. Another important consideration is lettering and marking, the aesthetic look of the casting. Lettering, it is a common practice to include some form of part identification, year of manufacturers, customer's logo, our own logo, manufacturer's logo, etc. in such a way that the casting looks good and it can be identified properly during the service. Okay, so these letterings and markings should be good enough, and there are some basic material like brass and aluminum. Especially the brass is very much suitable for making different types of lettering. Another consideration is the machining. Some of the areas, because casting surface cannot give you the such a good surface like the machining surface, some of the areas there is a matting of two parts. So sometimes because castings are made from sand, so there is some unevenness, so it will not match properly. So what we are doing now, we are putting some sort of extra stock on the casting. So that is called the machining allowances. Okay, that can be removed after machining. Another design consideration is that a part should be oriented in a mold so that the large portion of the casting is relatively low and height of the casting is minimized. Okay, and if we can have the access, we can have that option to machine, so we will try to make it that machining part on the top or coup part of the casting. Okay, the parting line is another important point. Okay, and as far as practicable, we should avoid step parting line, because step parting line again there will be some self type mold, and during we have to cut out the match plate to accommodate that self. So there are some complications. Okay, so next slide you can see it is a irregular parting line or step parting line. So by changing, modifying, manipulating the design of the particular product, we can make it a straight parting line. Okay, so we can conclude that if we can just remember all these points one by one in our mind as a practical foundryman, and if we can apply that points in our day-to-day activities, we can get good results. So casting design is a very simple subject if you can understand it fully. If you people like my videos, so please subscribe, like and share, and thank you very much for your patience viewing my videos. Thank you.